Hi guys, in this video we are going to see how we can work on the EC2 instance, and I'll be creating a couple of instances with different AMIs, one with the Windows operating system and the other one with the Linux operating system. And then I would be showing you how we can host a simple web application on one of the Linux instance. With these demos, they're related to security group, related to AMI, related to launching an EC2 instance, and how to work on them would be cleared. So let's look into it. You can see here, I have already logged in into my AWS account and I have selected the Ohio region. Now what we need to do, we need to select a service called EC2. I can open it from the console home under the recently visited services, or I can search for the EC2 service from the search tab. Let's say I open up the EC2 from the search tab, virtual servers in the cloud, and it will open up the EC2 dashboard. Now what we need to do is, we need to go to the instance and launch a new instance. And once we launch the new instance, we need to specify certain parameters. But before that, always verify the health of the region and the availability zones. How you can identify that? You have to go to the service health, look for the region, and here you can find the status is this service is operating normally. Then you have to go to the zones and you need to look into if there are any faults or errors in the zones. It will be displayed here itself. So no issues with the region, no issues with the zone. Now we need to click on the instances, and with the help of the instances dashboard, we'll be able to launch a new fresh instance. Guys, instance is nothing but a virtual machine. So AWS names the virtual machine as the instances only. All right. So I'm going to launch a new fresh instance. We just have to click on launch instances. And the first thing is we need to name our virtual server or an instance. Let's say I name the virtual server as Windows Server. Let me change it. And the next thing is we need to select the operating system image, because if we create a virtual machine, we need to add an operating system. We need to install the operating system on that virtual server. That's how we work. Let's say if you work on the laptops, if you work on the servers, what you do, or if you purchase a new laptop, you identify which operating system that laptop is having, whether it's having Mac OS or whether it's having Windows, which version of the Windows. Similarly, in our case, if we are going to launch an instance, we need to add or install the operating system. Ideally, we are not going to install the operating system. It will be done by the AWS in the backend. We just have to identify that this is the operating system we want to be running on a virtual server. All right. So how we can identify that? With the help of the Amazon machine image. So what is an Amazon machine image? It is an AMI, which is a template that contains the software configuration, includes operating system or any kind of an application or any kind of a runtime environment packages. So when we launch a new instance, AWS gives us some default AMI images which are widely used under the quick start category. So let's say if you quickly want to launch an instance, you can go to the quick start and select any of the most widely used AMIs. However, in case if you want to use a specific version of an AMI, let's say I'm going to launch a Windows operating system on this particular instance, and I'm going to install a 2016 Windows. So how I can identify that? For that, what we need to do is we need to go to the browse more AMIs, click on it. At the left side, you can filter the OS category Let's say I want all the Windows version. And here you get all the available Windows versions, AMIs, in the dashboard. I'm looking for specifically Microsoft Windows Server 2016 base, which I get it from here. And always when you practice on the AWS, make sure that you select wherever it is possible the free tier eligible. That would minimize the cost. What does this free tier eligible means? When we use this particular AMI on our instance, the AWS is not going to charge us for using this license or using this operating system image. I'll select the Windows Server 2016 base, and now it has identified. So on our instance, once we launch our instance, what would happen? The AWS is going to launch a Windows 2016 operating system over it. Now the next thing is we need to specify the instance type. Now what are the instance types? It is the type of a machine that we want to be created. How many computing resources the machine should have. Let's say if you create a virtual machine in the dedicated environment, you need to identify how many CPUs that virtual machine should have, how much RAM that virtual machine should have. So similarly, when we work on the AWS, we need to specify the instance type. Ideally, if you want to work on a free tier environment, the best thing is to select a T2.micro type of an instance that offers you one virtual CPU and 1 GB of RAM. However, if you want the larger servers, the bigger servers with more computing resources, you can click on compare instance types. So when you click on the compare instance types, you get the list of family of servers that are available with the AWS. And each and every server has its own billing rate on a per hour basis. T2.micro is free tier eligible, and in some regions T3.micro is also free tier eligible, which offers 2 CPUs and 1 GB RAM. So accordingly you can select. So I'll go with the T2.micro, but I'll just show you. If you scroll down, you'll get more type of a server. Generally T2 and T3 type of servers are small scale servers. If you want to have a higher capacity server with more, you can say more computing speed, you can go with C4 type of a servers. They are a bit expensive also. Then you have further to it, you have many other type of a servers. You can scroll it from this particular tab. Guys, these servers would be expensive, so just make sure that you select a T2.micro whenever you do the practice. Select the instance type. Now we have identified the Windows operating system AMI. We have identified what type of a server we need. The next thing is we need to create a key pair. What is a key pair? It is primarily required to securely log in on our instance. So when we create a key pair, the private copy of the key pair is installed on our local system, and the public copy of the same key pair is with the AWS stored. Now, while connecting the instance from any kind of a client application, we need to provide that key pair to the AWS so that it can match it with its public key copy, and it ensures, the AWS ensures that it's a genuine or a authentic user who is trying to connect to the instance. So I'll create a new key pair, and for that what you need to do is just have to click on create a new key pair, and here it gives you an option to create a key pair either in the .pem format or in the .ppk format. The .pem is primarily used as an encryption standard which is managed by the AWS, or it is mostly used for the OpenSSH. For Windows instances, let's say if you plan to launch a Windows operating system on your instance, it is always the .pem key pair that is created. The .ppk is used in case if you're going to launch a Linux operating system on your instance and you need to connect that instance from the PuTTY application. So right now, since we are launching a Windows 2016 Server Edition, I'll just create a key pair in the .pem format. And we need to provide the name for the key pair. Let's say I put something like Windows 2016 as the key pair name, or I can put a standard key pair name also. Let's say Windows instance. Now guys, if you create one key pair in the .pem format, you can use this key pair with multiple instances in the same region. So let's say if I plan to create another instance with the same settings, probably a different version of Windows operating system, still I'll be able to use the same key pair. It is possible. So it is not necessary that every time you create an instance, you need to create a new key pair. Alright. Click on create a key pair and you would see that the private copy of the key pair is installed or downloaded on my local system, Windows instance.pem. And the same key pair's public copy is stored by the AWS. Now, the next thing is network settings. We'll keep the network settings as default only. We are creating the entire instance in the default network provided by the AWS as of now. And from the security group's perspective, since we understood in the previous model that the security groups are the virtual firewalls, when you create a new instance, by default, AWS creates a new security group also, and it opens up the specific port based on the operating system as well. So in our case, right now, we are creating a Windows, or we are launching a Windows operating system on our instance. Hence, the AWS by default opens up or allow the RDP traffic on our instance, because AWS is assuming that we might require to connect to the instance using any Windows client application, and the RDP port has to be open, which is port number 3389. Now the location anywhere, which means a default IP 0.0.0/0, which means any IP address on the internet belonging to IP version 4 will be able to access our instance through the RDP port. That's what this security group means. But it is not necessary that we have to go with this security group or this security group settings. I can make the changes as well. I can customize it also. Or what I can do is, instead of creating a new security group, I can select an existing security group also. Let's say for any other instance, when I created the security group, I can use the same security group for this instance also. It is possible. Let's say I go with a new security group. I allow RDP traffic on this instance from any location over the internet using the IP version 4 format. In case if you want to modify it, you can select my IP also. Let's say if I move to my IP in this particular case, what would happen? From my network IP, I would be able to connect, or I'll be able to do the RDP to the Windows instance. RDP stands for Remote Desktop Protocol. But no one else outside my network would be able to connect to the instance using RDP. So that is what the beauty of customization or the benefits of using the security groups and the virtual firewall. Similarly, for example, if I plan to launch any kind of an application on this instance, so I may open the HTTP traffic on that instance. I may open the HTTPS traffic, and likewise there are other ports which we can customize later on also. It is not necessary that I need to go with the same security group settings. Later on, when the instance is created, I can modify the rules in the security group. I can open more ports also. I can open TCP port, UDP port, SSH ports. There are so many ports that I can open up. Okay. So right now I'll just keep it as anywhere as of now for the testing purpose. Now coming to the storage part. What we are doing is, we are creating an instance. We have selected the type of the machine, which is T2.micro, giving us 1 CPU, 1 GB RAM, But where exactly the Windows operating system files will be stored? And for that, we require a virtual hard drive. Just like a virtual hard drive, or you can consider that in your laptops or in your desktops, you have a C drive if you're using a Windows operating system. And on the C drive, all the important files, the operating system files are installed. Similarly, for the instance, we require the capacity, the virtual hard drive, where the Windows OS images can be, or the files can be stored. And that's the reason we are going to block 30 GB of block storage with the EC2 instance. Now, what happens in that case is, let's say you have one EC2 instance. Let me draw that. Let's say this is an EC2 instance that we are going to create. And the machine type that we have selected is T2.micro, which offers us one CPU and 1 GB of RAM memory. Now, about the hard disk or the virtual hard disk, it actually comes in a block storage in the case of a T2.micro type of an instance. So we have to reserve a block of a storage, which is also called as an EBS or the volumes, or you can call them as EBS volume also. EBS stands for elastic block storage. Why elastic? Because the capacity of this block storage can be changed later on also when the instance is in a running state. So let's say we reserve a 30 GB of a block, and then this block will be attached to our instance. Now what would happen? When the AWS starts launching this instance and install the Windows operating system, all the files will be installed on this particular block storage. And likewise, you can add more block of storages to the instance, and accordingly you can name them in a different drive format. We'll see how this drive is reflected when we'll log in into the instance once it is created. So I'm back to the AWS console, and 30 GB of the block storage we are going to reserve. And what AWS says is, till 30 GB of volume or the elastic block storage, which is a general purpose SSD that we have selected, there are no extra charges. We can use it as free tier eligible. But in case if I reserve a block of 30 GB, which is not a general purpose SSD, but a provisional SSD, which is faster than general purpose SSD, there will be extra charges for that. Even if I do not reserve an SSD, if I go with a magnetic storage also, 30 GB of storage will be free of cost, free tier eligible. Magnetic storages are the primitive type of storages that AWS provides, which are not SSD. They are slower, but they are cost effective. Now I'm going to launch an instance. Here you get the launch instance tab. Click on it. And the rest of the things in the backend would be taken care by the AWS. Once the instance is launched, we'll get an instance ID, and this is auto-generated by the AWS. We have to click on this instance ID, and it takes us to the dashboard where the instance is in a running state. So here you can see our Windows instance ID this, T2.micro has been launched in availability zone US East 2C. Now when the instance is launched, if you scroll down, you'll find you get a public IP address and the private IP address. Now this public IP address is dynamic one because allocated by the DHCP server of an AWS. But this private IP is the static one. Since we are accessing the AWS over the internet, so we need to connect to this instance remotely using the public IP only. The private IP is internal to the AWS network, so we won't be able to access it. Now I'll show you how we can connect to this instance. What we need to do, guys, if you're using a Windows host machine, you just have to copy the public IP, open up the RDP, client application, which is a remote desktop client application. This is an inbuilt client application in the Windows. And those who are using Apple or Linux based host machine, I'll tell the procedure to connect to the Windows instances for them as well. And in the computer section, you just have to provide the public IP address. Click on connect. It's gonna ask you for the username and the password. And where we can find the username and the password, we just have to go back to the AWS console, select your instance, click on connect option. Here you can find it. Click on connect, go to the RDP client and look for the username. The default username is administrator, A caps. Copy to the clipboard, paste it in the username section of an RDP client. Now the next thing is we need to get the password. So here you get the password option, but we need to get a password. And to get a password, we need to provide a key pair that we created when we were launching the instance. So click on get password. It says to generate a password, you need to provide me this key pair, windows instance.pem file. That is already stored on my local system. So I'll just upload this private key file. Here you get windows instance.pem, open it up, and then the AWS matches this .pem file with its public key copy and provided us the password in the encrypted format. Now we just have to click on decrypt password, copy the password to the clipboard and put it in the RDP client. Click on OK. That's it. Now we will be able to connect or remote connect to the Windows 2016 instance. Let's wait for it. So here you can see that now we are connected to our Windows instance. You can match the IP address, the public IP at the right side. At the top right side, you get the instance IDs, the public IP address, the private IP address, and the other details. Now just to verify the block storage, the 30 GB block storage that we have attached to the instance, we need to go to the C drive. So let's wait for it. So here you can see in the C drive the capacity is 29.9 GB, which is close to 30 GB, out of which only 10.4 GB is free. The rest of it has been taken by the Windows files. Now I'm going to show you how we can work on the Linux instance, or how we can create a Linux instance. But before that, how to stop your instance. You just have to click on the instance, go to the instance state, stop your instance, or you can terminate the instance also. Let's say if I click on terminate instance, the instance will be permanently deleted and then there will be no chance of recovering back. If I stop the instance, then I can start the instance again as well. Alright, but when we stop the instance, the billing also stops at that time, just for the awareness. So I'm going to terminate this instance, and you would find that I would be disconnected from the RDP client as well. Here you can see. Alright, now the next thing is we are going to launch an instance with the Linux operating system, and then we are going to see the difference in connecting the Linux instances. So to launch a Linux instance, the procedure is going to be same. Just that we need to select a different AMI and we need to verify the security group ports for the Linux instance. Let's look into it. We just have to click on the launch instance, provide the name of the instance that we want to create. Let's say I put it something like Linux instance. And again, we need to select an AMI. So I can go to the quick start and select an Amazon Linux AMI. Amazon Linux is the customized Linux environment by AWS, and that is the preferred one. Whereas in case if we want another vendor's Linux operating system like Red Hat or CentOS, we can browse for more AMIs and there we can filter out as well. I'll go with Amazon Linux as of now. The type of an instance is going to be t2.micro. The key pair I'm going to create a new one because this is going to be a Linux instance, so we would require the .ppk file. So I'll click on create a new key pair. Provide a name to the key pair. Let's say I put something like Linux instance. And instead of .pem, I'll create a .ppk, which is primarily to be used with PuTTY. Create a key pair. The rest of the things are going to be default. Here you would notice a new security group will be created, and now the SSH traffic is allowed from anywhere. That means from the public network, the SSH traffic is allowed. Why? Because the Linux instances are connected using the SSH port, which is a port number 22. Since Linux operating system is lighter as compared to Windows, so AWS recommends we can go with the 8 GB of block storage as well. But still, AWS offers us somewhere close to 30 GB of block storage, which we can use it as a free tier or free of cost. Just we'll click on launch instance, and here you can find another instance ID is created, auto generated. Just click on it, and this will take you to the dashboard and tell you what is the status of that instance. Now our instance is in a running state. We'll get one public IP, a private IP. Now how to connect to this instance? There are multiple ways we can connect to this instance. One is directly using a web console. That means I'll click on connect option here, click on EC2 instance connect. The default username is going to be EC2-user, and we just have to click on connect option. We don't require even a key pair because the authentication would be done directly from the console here. And in a new tab, you will find that we'll be able to connect to the instance. Let's look into it. So here you can see when I clicked on the connect button, it took me to the new tab, and here I would be able to connect to our Linux instance. So this is a web connect. And here you can see that I have connected to the instance with the default username as EC2-user, and the IP address that is reflected is the private IP address of the instance. You can tally that as well. So if I go to the instance in the EC2 dashboard, let's wait for the private IP. 172.31.39.227, and that's where we have logged in. So this is one of the way to connect to the Linux instance. Then I'm going to show you the next way, which is using a PuTTY client application.